Many of us know that the latest standard for the masses of atoms is called Unified Atomic Mass Unit. We understand why it is called atomic mass unit. It is simply a unit for the masses of atoms or atomic masses. But why is it called Unified Atomic Mass Unit? Remember, originally John Dalton took mass of one hydrogen atom as the standard to compare the masses of other atoms. After using it for nearly 100 years, we discovered many problems with this standard. And we also understood that we can measure the masses of atoms more easily and accurately if we take the mass of an oxygen atom as the standard. That is why I think around 1905, we defined a new standard and called it Atomic Mass Unit or AMU. And by definition, one AMU is equal to 1/16th of the mass of an oxygen atom. Remember, atomic masses are needed by both chemists and physicists. But chemists measure atomic masses using chemical reactions or chemical methods, whereas physicists measure atomic masses using what we call mass spectrometers or physical methods. So chemists measured atomic masses using chemical methods. Physicists measured atomic masses using physical methods. And everything was fine until the year 1932. In 1932, we discovered that all oxygen atoms found in nature are not identical, as John Dalton originally said. Oxygen atoms found in nature come in 3 different flavors with 3 slightly different masses. But they are all oxygen atoms, but they have different masses. Such atoms are known as isotopes, atoms of the same element with different masses are called isotopes. One isotope of oxygen is called O16, the second one called O17, the third one O18. Now, when we created this standard for atomic weights, we said one AMU is equal to 1/16th of the mass of an oxygen atom. Now, while creating this standard, we were under the impression that all oxygen atoms found in nature are identical. But in 1932, we found that all oxygen atoms found in nature are not identical. Now the question is, when you say one AMU is equal to 1/16th of the mass of an oxygen atom, mass of which oxygen atom? Is it this one or this one or this one? So now we have a little difficulty. Chemists said that for them, one AMU is 1/16th of the mass of an average oxygen atom, an average of these 3 naturally occurring isotopes of oxygen. But for the physicists, one AMU is 1/16th of the mass of the most abundant oxygen atom. Out of these 3 isotopes, O16 is the most abundant isotope. And an average oxygen atom and the most abundant oxygen atom do not have the same mass. Therefore, unintentionally, chemists and physicists ended up with 2 slightly different atomic mass units. Because of this, the atomic masses measured by chemists and physicists were not identical. And if you think about it, it is really Confusing, right? If you are looking for a very accurate atomic mass of an element, chemists will give you one value and physicists will give you a slightly different value. And this is a big annoyance. And after living with this difficulty for many years, in the year 91, they both agreed to replace their individual AMUs with a single new standard. That is why in 1961 we came up with a new standard that is called Unified Atomic Mass Unit, and by definition it is equal to 1/12 of the mass of an atom of C12 isotope. Because this new unit is unifying two different AMUs unintentionally used by chemists and physicists, it is called Unified Atomic Mass Unit. And this is what your textbook refers to as unified mass, rather incorrectly.